Alright, it's go time. Let's keep this streak alive. Remove the nth node from the end of the list. Remove the nth node from the end of a list. Yeah, we have a long way to go, man. Look at that. It's a lot of stuff, and then a lot of these guys. Oh boy. Yeah. It's a lot of stuff. Anyway. Oh, hash maps. Who knows what that's about? Okay. Anyway. Today we're going to remove the nth node from the end of a list. Okay. Remove the end from the list for open. Statement example, understand it from another figure, or try yourself. A singly linked list. Remove the nth node from the end of the list and return its head. Okay. No, this is K. That's 10 to the 4th. It's between negative 1,000 to 1,000. What is this? Okay. And it's 3 from the end of the list. So 1, 2, 3. Okay. Take that out. So 5 is not connected to 39. Okay. Interesting. And it's 5. 1, 2, 3, 4, 5. Okay. Take it out, so it's gonna get to 4. Alright. And return its head. The head of the linked list is the first thing. 1, 2, 3, 4. Nth node from the other list was the output. And 3, 1, 2, 3, 90 is gone. 65 is connected to 12. I wish there was a way to know the significance of this problem, what bearing it has with reality. 5, 1, 2, 3, 4, 5, 15. So 12 would be connected to 13. 6, 1, 2, 3, 4, 5, 6. 20 is 30. Okay. I think this should be number 1. Add the head of the linked list. And the repertoire is the last node. At this point, that point up to the node behind the nth last node. This is a bit more challenging. Okay. I think this should be last. Mm. Move the right and left pointer forward until the right pointer reaches the last node. At this point, we'll point into the node behind. I don't know. I don't want to waste too much time on this. Yes, please. Oh, wow. This step doesn't seem to make any sense to me. Pointing to the node behind. Okay. Hmm. Okay. Oh wow, this is like magic. Huh. Wow. Ah, it's using the difference. I wish I could draw this, but it actually makes sense. It actually makes sense. This strategy makes sense. Wow, it's like magic. Wow. Let me use like Scarlet Draw. So what's this? Whoa, what happened? Okay, this is like some weird thing. It's open. Profile. Nah. I just want a new thing. Okay. Nope. How do I like do something new? Reset canvas. Sure. I'm guessing I'm not allowed to do a new thing unless I pay or something. Yeah. Or, oh, I can save locally. Interesting. Can I Ctrl Z to reset canvas? Yep, I can. I'll just start a new thing over here. Okay. So let me do a thing. Let's say I use one of their examples. Yeah. I don't think. Okay. Oh, I actually can. How about that? How about that? That is so neat. So I have a left and a right pointer, and they said n is 6, right? N equals 6. Just for example. That's weird. So I'm supposed to remove the 6th item. So from the end of the list, so from here, 1, 2, 3, 4, 5, 6, I'm supposed to remove this. Is this a good example? Yeah, I can walk through 2 cases here. Then we'll realize. So let's say this. Let me use an arrow. This is my left pointer, and this is my right pointer. I wish I could color them. Can I? Yay. Okay. So left pointer. Can I give it like a title? That would be nice. Oh, I can. Okay. Left pointer. Then this guy. Right pointer. Ooh, I should have made this red. Yay. Alright, so So they're saying once you have this problem, let's go over this algorithm. Set the pointer at the right and left at the head of the linked list, because the linked list can only be accessed from its head. So this is the right pointer, and then we rotate this. This is the left pointer. Touch it, why not? Okay. And the left pointer and the right pointer. So set the 2 pointers at the head of the linked list. Check. Move the right pointer n steps forward. So 6. First is 1, 2, 3, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6. Okay. And then move both the right and left forward until the right pointer reaches the last node. Now notice that in this case, for n equals 6, it's already at the last node. At this point, the left pointer will be pointing to the node behind the nth node. I think I got it wrong. They're saying that this will be pointing to the node behind the nth node. The node behind the nth node, that's assuming this is the nth node. But okay, let me start again. It started out here, right? So 1, 2. I made this 0. At first I made this 1, but now I'm making it 0. This is number 10. So 1. I mean 1, 2, 3, 4, 5. No, 6. So wrap around. Then move them both until the right pointer reaches the last node. Okay. Now move them both. They landed at the same place, right? So I'm gonna move them both to the last node. That's 60. Okay. At this point, the left pointer will be pointing to the node behind the last node. So this is the end of the list. So I assume it's gonna wrap around, because after 60 is the end of the list, so it wraps around to 10. So 60 is behind the one that's supposed to go out, because remember 10 is supposed to go out, right? We know that 10 is supposed to go out. Oof, everything changed. No, please. No, sir. Yeah, I'll just circle it. We know that this is our target. This is what's supposed to go out, right? So it's pointed to the one behind what's supposed to go out. So relink the left node to the node next to its next node. Okay, so I'm supposed to relink this. It's supposed to relink that to the node next to it. Next to relink the left node to the node next to the left's next node. Okay. That's weird. I think this is a special case. Try the normal case, base case, n of 5. Because in this case, 15-bit dust is a special case. Okay, it's a different case. In this case, n is 5, I believe. And we know that this guy is the target. We know that guy is supposed to go. Okay, start from here and go for the ride. Okay, follow the recipe again, see if it makes any sense. Head of the linked list, move the right pointer n steps forward. N is 5, so move this 5 steps forward. 1, 2, 3, 4, 5. Okay, now until the right pointer reaches, okay, move the right pointer n steps forward. Now move both of them together until the right one reaches the last node. Now in this case, maybe another special case, is already on the last node. At this point, the left will be pointing to the node behind the nth last node, which is true. So that means I'm supposed to start moving counting from here. Okay, behind, so it is, right? Because this was the target, this is behind. And I can do as a solid actually, and probably just put these side by side. Showed my email. Okay. How do I hide this thing? There we are. Okay. Where are we? Wait, is someone invited to this thing? No, good. So the last node, check. At the point, the left pointer will be pointing to the node behind the nth last node. Yep, it is. Relink the left node, relink 12 to the node next to relink this 12 to 13, they're saying. So I wonder if, so I need to relink this. I wish I could curve it a bit. I think TL draw lets you do that. To relink it like that, and voila, profit. So once I relink this, I always kept track that this was the head in the first place. The issue with this case is that the head had curtains, right? So let me try this again. So I started from here. Now I know based on n equals 6 that 1, 2, 3, 4, 5, 6, right? From the last node, starting from null, 1, 2, 3, 4, 5, 6. Okay, so set the two of them at the head of the list, move the right pointer n steps forward, 6 steps forward. 1, 2, 3, 4, 5, 6. Okay, it's pointing at null if possible. Let me just give it a whack because why not? Okay, move both of them forward until it reaches the last node. Now null is not the last node. 60 is the last node. But let me assume null is the last node and see what happens. At this point, the left pointer will be pointing, so move it until the right pointer reaches the last node. Okay. think you might have to wrap again. Oh boy. This is super confusing to visualize. Or maybe I'm just tired. It's been a long day. So I did 1, 2, 3, 4, 5. Then move. This was already pointed at the last node. In this case, if I do 6, it's 1, 2, 3, 4, 5. Then wrap around 6. Then move both them until on the right reaches the last node. In this case, the head needs to go. I wonder what happens when the tail needs to go, actually. At this point, the left pointer will point into the node behind the nth node. Okay, assuming I'm wrapping around, that is true. Relink the left node, relink 60 to the node next to its next node. Relink 60 to 20? No, that's wrong. The head needed to go. In this case, relinking 12 to 13 makes sense. But in this case, I'm not supposed to link 60 is not supposed to be linked to anything. Neither is null, neither is 20. This is just supposed to drop its link. So this algorithm is sketch. Yeah, it's kind of a sketch recipe. That doesn't work. That does not work. Change my orientation a bit. I don't even know how I look right now. Oh, they can't see my face. My beautiful, beautiful face. Oh boy. Let's get to work. Why is my face so high up here? Shouldn't be. I've probably been covering a lot of the code. Then take this in. Nope, I don't want it to zoom in like that. I can alt click. So it doesn't crop me. Don't go cropping me. Nope, not you. Don't go cropping my heart. OBS. Such an interesting piece of software. Okay, this is me hoping I've not been blocking the whole thing up until now. Alright. This algorithm is sketched. This recipe they gave. Yes, it is. It is pointing to be the node behind this. If you're wrapping around at the end. Link it to the node. No, that's sketch. That ain't it, chief. That ain't it. In this case, I'm not relinking anything. So just to make sure no one's confused. What does this do? Oh, cool. This guy. Can I hide this thing? No. If it was here, it wouldn't work. If it was here, it wouldn't work. Here it wouldn't work. I think the rules are different. If it lands on the head, so I need to take note of when it lands on the head node. The recipe is different. That's what that means. So always I need to add a check. Check if node to be a special case of left node at tail, right? Because it means I'm not reconnecting the node, I am just pointing it to null, basically. Pointing the head to null, the former head to null, and moving it one step forward. Because it works, it checks out here. Just connect this to the one after this, and point this to null, basically. So yeah, I think those two cases are nice. There's a happy path and a very sad, depressing path. The third to the last element has to be removed. Okay, let's check this last example. Okay. So if I place this gentleman here, in this case, n is, I don't know what n is. N is 3. So account for 3 from the end. 1, 2, third to the last element. Yeah. 1, 2, 3. 1, 2, 3. This guy is supposed to go. 1, 2, 3. That guy's supposed to go. Starting from the beginning. Take note of the head. Just put all the nodes, all the special nodes in one place. So now, step. Move this forward n times, so 1, 2, 3. Then move the two of them until the right node is at the last node. So that's just one step. Okay. And then this, reconnect this to this. This to this. Period. That worked very well. That's how you get this answer 78. Just connect it to, wait, 65? Oh shoot, I missed 65. How did I do that? Whoa, I did the same. Where did 65 go? Oh shoot, that's the wrong answer. Oh man. Gentlemen, please. Oh, this is the reality of studying. Really. There's fancy, happy paths, and then there's reality. You know, there are fancy, happy paths, and then there is reality. Let's start again. Okay, 3 times. 1, 2, 3. Then move the two of them until this guy's at the end. Okay. 2 steps. Then connect 65 to 12. And we're happy. Checks out. How much battery I got left? 4%. I'm gonna be tired already. How long have I been recording? 30 minutes. I'm gonna pause it. I think we are back. Yeah? Yeah. That's weird. Alright, we're back. Kinda like we never left. But let's get this streak for the day. So that's the lingua there. I can get this out, show this up. Where the nth node from the list is loading again, because I don't know why. My internet's decent. Yeah, good enough. Did all this stuff. Now we need to do this. So remove the nth node. It's the head, the passing the head node, and the number. Then return the head. Remove nth last node. Okay, it's the linked list implementation. It's got its data and it's got next. Okay. So this is brought into here. Yada yada yay. Insert node at the head. Okay. So like this. Head is equals node. Yada yada yay. Okay, interesting. Okay. Okay, this looks interesting. So I have a head node. You know what I'm gonna do? I will copy all this stuff. Save? No, copy. Take this to VS Code land. I need to make sure I'm not showing anything proprietary before I do that. Alright, we're back. So now we're not doing sum of 3 numbers. We are doing, take this aside. We are doing remove nth node from end of list. Right, that's the title. From end of list, and then you can just remove nth node from end of list. That's yes, use TypeScript because why not? And then I can actually move this off to the side. Copy the helper libraries they have for us. This guy. Honestly, I don't need this. Export this.data. Exactly. It's fine. Yep. Then I don't need this import because just putting everything in one file because I can. Yay. And then don't need this export. And then I can sort of copy the main.js, the big guy. Go. Just spread this a bit because I'm not really seeing it. This is the function. These are my helpers. And I can just do some code foo here, and any, it's not any, it's actually a number. Same here. No, it's another one actually. And I think do this if you want it to live, or actually it can be null now that I think about it. Okay, the head is not defined. I probably for head because TypeScript likes that type of thing. You know, head is not null. Head is a linked list node. Oh, Copilot is there already. Awesome. And then this guy. This is not null. This is insert node at head. Linked list node. Save this so I get auto formatting. List is so it's an array of numbers that looks like this. It's a number array. And what else is weeping? This is weeping, gnashing teeth. Display is a function. Doesn't take anything. Returns a string. Awesome. I think TypeScript is not crying anymore. Yay. What's next? Now I need to implement what I mapped out. Basically, this jazz. Start off left and right of the head. Move the right n times. With right n times, and then move both until the right is at the last node. So basically do that, but I think I have to create a linked list first from the array. Does that happen at the constructor? New construct. If I call the constructor, what's gonna happen? It runs all these ops. Actually, so yeah, it does happen at the constructor. Anyway, remove nth last node. So they give me the head. This is me hoping I don't have to create the list by myself. A head and n. Okay, interesting stuff. I'm assuming okay, they do the creation under the hood of these items of the linked list class, an instance of the linked list class. I assume they do that under the hood, but they pass me the head node. I'm going to assume is of type node. linked list node. N is a number. Oh, Copilot is gonna try. Not trying to do everything for me. Nice. So first of all, I have a number that I feel like I have to loop through. I feel I'm obligated to loop through. Okay. And I need a left pointer actually. Let left node equals null for now. Actually, they should all start at the head, so I should say head. Okay, right node is head. Okay, and for the first loop, I don't want to do that. What I want to do is set the right node to the next so amount of times, and okay, if the right node is not null, do that. Otherwise, set it to the head. Nah. Set the right node to the head. Okay. So loop through it. If the next is null, well, it's not null. Be careful with this JavaScript stuff. Set it to the next thing. If it becomes null, go back, loop around. Okay, be nice. And then after that, I need to say that we need to move it up until yes, while it is actually that is correct. I don't know if they'll let me use Copilot to do this, to work in an interview. Okay, the null. You see, TypeScript helps you catch these errors, right? Where, oh, I've actually reached the end of the list, you know? Whereas null, JS would just be like, oh, fine, do whatever you want, man. Do whatever you want. So yeah, well, it's not null, and then I need to know if the left list. I think this is when the special case that I mentioned. Take note of the head node. That's the special case of the left node at the tail, right? If it winds up here, in which case the thing I'm supposed to remove is the head node, actually. So and I'm supposed to stop the moment I reach that. Well, the left can never be after the right. You know what, I'm just gonna type something. If the left node .next is not null, then do it. Right. And then which probably can't be actually. How can I fix that type error? Well, maybe stepping through the debugger will help me figure that out. In the meantime, okay. In fact, I think I can just mute this until I figure that out. Then I have to do the special case. So now it has looped through and moved everything to its rightful place. After doing that, I need to if it's not null, actually let me handle the case if it's null, because why not? If left node .next, if it's null, right? If it's null, what should you do? If it's null, then that's the special case, right, where the head is the problem. the head is the problem. So like this special case here, where 10 was what was supposed to get curtains. So in that case, I should point the head to what's next, and or no. Oh, because I said in here the next is linked list node or no. Interesting. Because if it's a one element, what do you do if it's a one element linked list, right? So I just add that case here. TypeScript helps you make great code, man. Head dot next. If it's null, then return null, because bro, it's the ghetto for real. Okay, and then that goes away. Now there's still this case where the left node is pointing to something that is not the right thing. I can just do this, honestly, because it's always going to be, it cannot be after the right node anyway. So yeah, that's not possible. It can't ever be after the right node, because the right node always stops here, right? And the only time I move the left node is when I'm moving both of them at the same time. So there's no scenario where the left node is ever after the right node. Diagrams are super useful. So yeah, I'll just keep that. It's pretty procedural. I wonder what the big O of this is. I'm curious to find out. I can guess it's going to be similar to the last one, where we had n log of n for sorting the list, and plus the worst case, where you go through every item once. What was the big O of that? I'm curious. I forgot. I'm trying to recall. I've tried to recall it, but it's been a minute since I did any of this stuff. N squared, yeah. Worst case is n squared. It simplifies to n squared. N log of n is a sorting algorithm performance in the beginning. N squared. You always pick the bigger one when you have these additions with bigger notation. So it's going to be this. So it's the best we could do, but better than the naive case, because the naive case would have been n cubed, right? That last time. Yeah, so significantly better, an order of magnitude better. So I'm guessing this is worst case you move it once, like worst case you're iterating through the list once. That's O of n. But the right node will never pass here, right? So I'd say it's never going to pass here. And then the left node might move a few steps, right? So it's like n plus n, just still, or O of m plus n, right? That's like a popular asymptotic. Usually just have something like this, of m plus n, which like winds up being like big O of n. Pretty much, that's my guess. But let's find out, shall we? Let's try and finish this off. So if the left node is next, which we're at the and special case where, actually I should say that, special case where we're at the end of the list. Come on, type. I need to remove the head. Where the left node pointer, actually. Yeah, so just set the head to what was after it, and turn the head, actually. So that's one case. Otherwise, if we're not, then do the thing, right? Set the left node to the thing after it. Dot next. because it for sure is defined. And return head. I think this should actually work in theory. But let's test that theory. Probably ain't gonna work, but we are not discouraged. Amen. Amen. Praise the Lord. Then I have to, of course, remove the types, TypeScriptings that I added. I don't think this is allowed in TypeScript in JavaScript land. I don't think this is allowed in JavaScript land. Oh, I did this twice. Go away. Thank you. What is going on? Is this being used? It shouldn't be used. I'm assuming they're passing me what I need, right, in the function, the head. And I'm hoping, oh, don't tell me, because it's a head, right? The head is not this whole array. I hope they're passing me an actual linked list. Yeah, I hope, because they kind of obscured all that. Oh, where's run it and see. Wow, first try. Who would have thought? Incroyable. I actually pulled it off. Look at that cheese, man. Look at that cheese. I made a splash, baby. 1, 2, 3, 4. Look at that. Look at that. 1, 2, 3, 4, 5. Ah, this was that special case. They think they slick. Ooh, they think they slick. They think they slick. Ooh. This is 1, 2, 3, 4, 5, 6. Yeah, it's a special case. Look at them. They think they're smart. 1, 2, 3, 4, 5, 6. So yeah, I guess I did a thing. It's nice. Oh, run and submit. Do the same thing. Oh, you can submit after. How about that? Huh. Okay. Mark this as complete. Thank you, sir. Did I submit here? You know, I don't know. Ooh, look at that. I got what I wanted. This is what I came for. Are learning streaks helping me with my learning? Yes, most definitely. Yes, most definitely. Zoom, 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 zoom. Learning streaks are the best, man. So, but the only issue, I just wish, actually I should have sent that. I wish I could skip weekends, because I don't want to be grinding educative on weekends, you know. So there's that. I think this is what I did. Solution, commented solution. Oh, they have a solution and a commented solution. How about that? Oh, love it for them. I love these guys, man. They just keep exceeding expectations, yo. They keep exceeding expectations, man. So let's go through the solution. An educative a day keeps unemployment away. I don't know if I'll have energy. I'm just play it safe and call it a day here. Honestly, I still have these to do. I have 1, 2, 3 of these to do. Should be done. It's Saturday, and Sunday, and Monday. So remember the end of this is the 2-pointer pattern. And there's a naive approach. You know, they pretty much give you the answer when they give you those breakdowns, you know, and it's encouraging because you should probably look at the answer first and try and step through it. It'll help you like internalize the pattern better, and you can come back and remember it later on. But this technique, I think this is actually a novel like problem solving technique for this type of thing. If you don't know that, you can like use something like the distance between the two to do what you want. You'd completely miss it, you know. So they say a lot of stuff. Say pointer at the end of this movie where this which is like to save the next node of the pointer and the temporary pointer. Everything's pointed to the node. Let's delete the node. Okay. Calculate the length of the list. Oh, by going through the whole list first. Now you don't need to do that. Then we set pointer at the start of the list. I'm moving through the list till it reaches the k minus n minus 1 node. Okay. The temporary pointer. Relink the pointer node to the node next to pointer next node. Delete the node pointed. Oh, was there a delete function? I didn't even check. There isn't. The node pointed by the temporary node by day, so the nth node will be removed. However, this approach traverses the link twice. Let's see if we can use it to run it in a single pass. As by the left pointer will be pointed to the node before the target node. Alright, there's just no. Then move to right. Yep. 1, 2, 3. Then. Oh wow. Did they look at my code before they came up with their solution? Because what? Well, right, the next is null. If there's no right, the next. Return head.next. Okay. And that's if I didn't handle this case. Single element case. That's what this is. Right. Or maybe not. Wait, what is that? Is that the same thing? Head.next. Oh, okay. Yeah. And oh, interesting. If you wound up at the end of the list the first time, it means the left is okay. I get it. They're saying if you wind up, if you count 6 steps, 1, 2, 3, 4, 5, 6, and you're here, then you just need to remove this. So I could have simplified my code actually. If that's interesting. Yeah, that simplifies the code quite a bit actually. If I wound up at the end, right, after just moving the pointer to the right place, then just remove the head. Yep, which is what I did here. Just remove the head. Head equals head plus next. I'll just return the head next actually. Because you can't go back as a one directional thing. So I didn't even need to just set it. I just needed to. Okay. Fairs. Interesting. And then move all pointers into the right pointer, which is the last node. Wow, it's not null, right? Yeah, just keep moving. There it goes. Yep. Yep. So very similar code. But theirs is not asymptotically better, but just a lot cleaner in that how they handle that case. So they're saying once I've done everything, if it's not null, set it to next. Right, that's TypeScript. Just and I don't need to do that, right? Because basically what they did, they said if right equals right on next. What happens if I move this up here? I know things about n already though. I have to never exceed the length of the list. So I can do that. Right. I can use this. Oh, close enough. So keep going, keep going, keep going. And then I can say if the right node is null, return that, period. Okay, so otherwise, while it's not null, I think it's the same thing. Yes, same thing. Same thing, same thing. I think I wrote the same thing. A lot cleaner there. And if it's null, if it doesn't exist, yeah, close enough. Turn this falsy, and then well, this is not null. That is probably the left pointer. Let's do this. Then I had the next. Nope, I found that special case already. And period. Done. I love it. Nice. It's looking good. It's looking great. Oh, Van. Yeah, I was right. I didn't do space complexity, but you'll have to forgive me. Yeah. Autant. It's pretty late. Video has gone on for long. I think I'll call it a day. I wonder how many courses there are here and how many days it will take me to finish everything here. So here I have 1, 2, 3. Okay. I can just do an average. So 1, 2, 3, 4, 5, 6 problems per section. I think 1, 2, 3, 4, 5. Yeah, 6 problems. How many sections? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh boy, 11, 12, 13, 14, 15. Still 6 sections? Yep, looks about it. 16, 17, 18, 19, 20. Wow, 21, 22, 23, 24, 25, 26, 27. Okay, so like 26 sections, and then one of them has a ton of questions. Boy, look at that. So am I deceiving myself? I hope not. What is 27 times 6? So 162 days. That's almost half a year. And that's a happy path because the last one has like 40 questions, yeah? I think. Yeah, this challenge yourself has like 40 questions, so this is not looking fortuitous. 162, let me do 26 times 6, 156 plus 40, 196. That's 196 days of coding things, and that's just the first pass. Knowing how the brain works, you want to do like space repetition, space review. So a problem a day will take more than 196 days. So it's either I do 2 problems a day and cut this in half, so that I do what, 98 days instead. Do it in. So the happiest path is for me to run through everything here in 98 days. 98 days is a long time. How many? 98 days. The months is 3.5, almost longer than 3 months. So we're in September. So we have September, October, November. Oh, we can do it before the end of the year actually. Then December. Huh. Okay. Can actually do it before the end of the year. If you do 2 a day. It's the only way. Interesting. Good to know. That is not convenient at all. Because then space review says even if you do it once, you want to do it again before at least twice, then it's probably with you for maybe what, the next 3-4 years. You probably won't forget any of it. And then if you have it, oh wow, do you think I'm pregnant? So 2 per day is 3 months, 3.2 months. 1 per day is going to take 6 months. That's a long time. I don't think I have 6 months to go over everything here. I want to do more, better. What can I do? What can I do? What can I do? What can I do? Am I going to do this? Are you going to do this, Maiwa? How long has this video been on? It's been on for 1 hour and 7 minutes. Am I willing to spend, what, maybe 2 hours a day on this? Count the cost before you start any project, Mayo. Count the cost. What's it gonna be? What's it gonna be? It's like a college degree, not like a college course, like a 2 credit hour course, I think. Like 2 hours of instruction count as a 2 credit hour course now, because you're supposed to do more, maybe like a 1 credit hour course, like a self-imposed 1 credit hour course. Because it's 6 problems per set. Let me go to a random section. Yep, 6 problems per set. 1, 2, 3, 4, 5, 6. 6 problems per set. We are grinding lead code or educative. 6 problems per set. This is not easy. 3 months, best case. I wouldn't consider myself prepared after doing it only once though. You do it, then you come back and start again take it from the top after going through everything here, just so that you have enough space between the last time you did the first thing and the second time you're going through it. So at least 6 months. Yeah, let's go. Let us do it. Should I start today? Today time is far spent and I'm gonna be busy tomorrow. Part of me is thinking I should. Let's look at the question. If it's easy, if I feel like it's easy, I'll do it. If I don't, still tomorrow. Sort colors problem. Statement examples, understand the problem, figure it out, try yourself. An array of colors contain a combination of the following 3 elements. 0 is red, 1 is white, 2 is blue. Very American. Sort the array in place so that the elements of the same color are adjacent with the colors in the order of red, white, and blue. The function should return the same array. Should only return the modified colors array. Okay. Okay. Oh, I see. Oh, okay, that's interesting. So, sort them. So one example is scattered. Just make it so it's red, white, blue. Okay. Okay. Fairs. How would I do this? This doesn't seem too bad. Make sure that we correctly understood the problem. The quiz below helps you check if you're solving the correct problem. What's the other following array if the following array is given as input? 0, 1, 1, 2, 2. I think it's this. Yes, sir. That's what's up. 0, 0, 1, then a bunch of 2s. 0, 0, 1, then a bunch of 2s. Yay. 3 zeros. 4, 5 ones. 3 zeros. 5 ones. How many ones? 1, 2, 3, 4, 5. 1, 2, 3, 4. Ah, no, that's wrong. 3 zeros. 1, 2, 3, 4, 5. Yep. Yay. Figure it out. Rearrange it. Okay, so I need 3 pointers. I think that should be number 1. Initialize to the array starting index. White initialize to the array starting index, and blue to the array's last index. Ooh. Okay. Otherwise should come after if. So if colors white is 0, red is 0 actually. White, it stands for 1. Yeah, 1 stands for white, 0 is red. Alonso Fondi la patrie. Because the French flag is also, that's their anthem, and the French flag is also red, white, and blue. Yana yana kaina sopra. Soprenene comprende con a shiny kakani. Vande nano siko sieni. Fenede gene menoko domagane mandes. Brate dere pedora parate kito menede. So if the color white is 0, if color is white is 0, index at white. We sort the values of white and red. We also increment both white and red pointer by 1. Ooh, okay. Otherwise, it'll be 2. So swap it with blue. Decrement the blue pointer by 1, the one at the edge. This is not bad at all. If it's 1, the number is already in the right position, so no swapping is performed, and we just increment the white pointer by 1. Okay. Okay, I think that's... Yes, I wish this dialogue was higher. Yay, I got it. Now I'm supposed to implement it. How long is this gonna take me? I feel like once I know this, I can translate it to code fairly well. But I feel like I can translate it to code very well. But I'm tired. I can just do it tomorrow. Yeah. I'll start the 2 problems a day by tomorrow. So it should be scheduled to finish, worst case, by December. I'm just going to give time for maybe the harder ones, the ones for the days where I can only do 1. So yeah, that's it. Uploading to YouTube now.